What's up? This is Pang from LabVIEW by Example. It's good to see you again. In this video, I'm going to write some LabVIEW code showing you the benefits of using arrays. This is a continuation from my intro video on arrays, so if you haven't seen that one, go ahead and check that one out first. So, from my last video, I described a situation where you were tasked to write a program to simulate a car race. You're given 4 cars and need to return the position of each race car at various spots during the race. So let's see how we can do this first without the use of arrays, and then I'll show you a better solution using arrays. So let's fire up LabVIEW, and I already created a VI. Okay, for any point in the race, we can just run this VI and it will return the position of each car. So since this is a simulation, we can just use a random number function to generate the positions. Okay, so let's create some controls and indicators on the front panel to start off. So let's use the string to keep track of cars. So we know what the output should be. So there should be 4 strings. So let's get 4 string indicators. So this is going to be the first place. I can do a copy paste. Second. Third. And last. Okay. Let's line these guys up. Okay. Then I need to have 4 string controls for car 0, car 1, car 2, car 3. So let's go ahead and do string controls. So these are let's call it car 0. And when I do that, and if I do a copy paste, it will automatically set the numbers for me. So let me line these up as well. Okay. Okay. So we have that is so. So the first step is to find out which car out of the 4 should be in the lead. Okay, so let's use a random number generator. So if I drop down the random number generator, which is under numeric random number, and I look at the help, it gives me a double position floating point number between 0 and 1. Okay, so that's not exactly what we're looking for. We need a random number from the set 0, 1, 2, 3 to pick out which car to return. So how do we get that set? So the answer is scale the 0 to 1 range. So if I multiply that number that random number generator outputs by 3, okay, now I get a uniform number between 0 and 3. Okay, so but I don't need the numbers in between. I don't need the decimal point numbers. So all I need to do is convert that to an integer, and it'll just round to that integer. Okay. So I can wire this to an indicator, and if I want to do a quick test, I can just run this a few times. I'm just hitting Control R, or I can hit this button. You can see that number is randomly between 0 and 3. Okay, quick check there. Okay, so for the first stage, I'll need to use this number and pass it to a case structure And from this case structure, depending if it's 0, 1, 2, or 3, I picked the first place. So I need to take all these control values into this case structure here. So for 0, I'm going to wire this to first place. And if it's 1, take that. And then the others, I'm just going to pass them through. And I can duplicate this case for 2, and duplicate this case for 3. And for 2, we need to take car 2 out. And then wire this here. And then for 3, I need to take 3 out here. Right. Take that out there. So I have 0, 1 is first place. 2 is first place. And 3 is first place. Okay. All right. So in the second stage, I just need to do the same thing, but this time I need to take only a range from 0 to 2, since we only have 2 cars or 3 cars to process now. Okay. So same idea. Case structure here. Second place. Take the remaining 3 cars, because we already know the first car. And then pick one from 0 to 3. Oh, I'm sorry, 0 to 2. So 0. 1. 2. Okay. And then for the final, we can do the same thing. Okay. Let's move this down a little bit. Okay. So here, I just need to take this. I don't need to multiply by anything because I just need a number from 0 to 1 and just convert it to an integer, and then pick one of these two to be first or third or last, right? So 0, So, and 1, we can swap these. Okay. All right. So now I can just run this. So let's go yellow, red, green, blue cars. And if you run this a few times, see that we have a random result of the various cars. Okay. Okay. So that works. Progress. All right. So let's take a look at how we can improve things by using arrays. So let me go ahead and minimize this, and let's bring up another VI. Okay. All right. So let's create a new VI. Well, I already did that, and drop down a string array indicator this time. Okay. So from our last video, I was using constants, but this time we can actually use a array indicator. So that was a control. Let's make that an indicator so we can drop down a string into this array here. Okay. So this array will hold the names of the cars, with the cars in the lower indices having the highest position. So the first car will be here, and the last position will be at the bottom. Okay. So I want to create an array control to contain the names of the cars that will be used in the race. Let's call this positions. Okay. All right, so like in my last video, this number is the index. So whatever value here directly to the right of this number is the index into the array. Okay. So when working with arrays, we can take advantage of looping such as for loops and while loops. Since LabVIEW knows how big the car array is, we can use a for loop and loop on the number of elements in the array. So let me drop down a for loop. Under here. And loop on the number elements in the array. So you do that by getting the array size, and you always have to subtract by 1. Oh, I'm sorry, that's not right. Just array size. Okay. So in our non-array code, we had to find a number using a random number generator, picking out one car at a time from the set of cars and doing the same thing over and over for the remaining cars. So in our first iteration, we need to generate a number from 0 to 1 minus the size of the array. So for example, for 4 elements, we need a random integers from 0 to 3. So we can use this array size function, subtract 1, which is here, subtract 1, and use that as a scaling factor to the random number generator. Okay, so if we subtract this value from the iteration terminal of the for loop, and we scale that with the random number, and then like like in our last non-array example, we have to convert that to an integer. Voila, we get a value that's correct for every iteration of this loop. So let's go ahead and put this in here: red, yellow, green, blue. Okay. Okay. So so if I want to do a quick check of this, I can go ahead and just wire this out. So when I do that, it creates a tunnel with this icon having 2 brackets. Okay, so that means that LabVIEW is auto-generating an array with an element added to the array at each iteration. So to create an array, I can just right-click and say create indicator. So I'll create an array here. Okay, and then if I run this, so I have 4 elements, so it'll go 4. So as you can see, this first element here is a random number between 0 and 3, random number between 0 and 2, 0 and 1, and the last one's always going to be 0. So seems to look correct. So okay, so we don't need that anymore. Okay, so now we have a number, but how can we use that with the array? Well, from the non-array solution, we had to pick a card from a set of cards. So we can apply the same logic here using arrays with the delete from array function. So this function gives us one element, returns an array with the remaining items. So delete from array here. So let's drop down that function. The random number can be used to wire into the index terminal. Okay. Okay. So we need to pass this shrinking array. So it's going to shrink every time because we're pulling one element from it every time. So how do we keep that array from iteration to iteration? A shift register. Yep. So to create a shift register, you add shift register here, and you can pass in the beginning array, pass that into this function here, and then take the output of that to here. Okay. All right. So now let's get what we came for. Let's build up the array to wire to this position's array indicator. So we need to build the array. So what we can do is just take this deleted element and pop it right out here, and like I showed you before, it creates an auto indexed tunnel. Okay, it creates an array by default, and then this can be wired to the positions array. Okay, no errors. So let's go ahead and run. Okay, and I get a random set of car positions. All right. All right, so you may be asking, what's the problem? Both ways work. So how do we choose which one, which way to code? So let's consider a few points. So one, the wire count for the cars. So the non-array solution had a bunch of wires, one for each car. There's some pain here, but not too bad. But the array solution has only one wire containing the array for all the cars, and another wire that returns the positions of the array. So there's some positives there. Code duplication. The non-array solution requires a random number generator that's copied and pasted, and logic in the case structures to pick which car to return. So copies of code here and here and here, and that's always a sign of more pain down the road. Where the array solution generates a random number in one spot. So there's only one place where that lives, and if you make a change here, it changes everything, okay, which is a much better way of coding. The next point is the ability to scale. So adding or subtracting the number of cars requires you to touch every piece of the code in this non-array solution. So if I wanted to add a fourth car, so say I add car number 4, what do I have to do? You have to create another case structure, copy this, wire some more. So as you can see, that's a lot of pain. But the array solution can handle any number of cars without even touching the code. So if I put pink here, and I run, works out of the box. Okay. And then finally, say I don't want to use strings. I want to use some other data types, numbers, or maybe a enum, which I'll go through maybe in another video. The non-array solution requires you to change all these data types to that new data type. So that's pretty painful. But in the array solution, there's only one or two places where you need to change the data type. And when you do that, LabVIEW adapts those wires automatically. So to show you that, I have an example here where I created a picture data type, okay, that has 4 pictures of cars in this ring control, picture ring control, okay. So instead of using strings, I can just delete that, drop that in there, okay. You see already these wires change from pink to blue, and I can make that, let's make that 4. Okay, and of course I need to remove this guy and copy paste into there. Okay, and see this is grayed out, there's no values in here, so let's make this yellow, red, green, blue. Okay, and for some reason this turn into an indicator, so a control, let's make that an indicator. So with a few clicks, I changed the data type from string to this image ring control. So I can run this now, and as you can see, it randomly picks the cars, and you can visually see what's first, second, third, and last. Cool. All right, so the bottom line, for problems like these, the array solution is the logical choice. In most cases where you're dealing with a set of similar items, put them in arrays, use loops, auto-indexing, and all those cool array functions that LabVIEW offers, okay, on this palette here. So, bunch of options, okay. You'll have a better chance of success in the long run if you do that. It's not totally painless if you don't use arrays, but it's more beneficial to use arrays when you can. All right. Congrats! You now understand the pain when not thinking first about harnessing the power of arrays. Now go off and write some VIs using arrays and see what other fun things you can do. Please, if you like this video, add them below, and don't forget to subscribe to this channel. If you need more LabVIEW how-to articles, go to labviewbyexample.com, and remember, you too can be LabVIEW awesome. Thanks for watching. Until next time.